Welcome to SWAM course on Design Thinking and Innovation. This is week 4. We're going to be looking at a case study, a very interesting case study, a product design of a pesticide sprayer for agriculture. So it's week 4, section C4. In this section, we'll be looking at design of a solar-powered pesticide sprayer. The project was mentored by Professor Avinash Shinde, faculty at the IDC School of Design at IIT Bombay. The student is a Master of Design, Product Design student, Ajit Debe. The student has taken all the phases of the design thinking and innovation process to do this particular project. He has done the primary research as well as the secondary research. So, the secondary and this primary research actually gave him the inputs. He analyzed this data, came out with a brief for the project, did ideations and did several alternatives. In fact, he built prototypes in the laboratory and the workshops, tested it out, got feedback, and out of this evaluation, he actually finally came out with the solution. Okay. So, the reason design thinking and innovation process is very important is that it is a very logical and methodical process. So, when you do take the process into account, you actually are finding reasons to justify the actions that you take further on. Okay. So, it means that for every stage of the process, you actually go about it very logically with reasoning at the back of it. So, let us have a look at the project. It starts with an introduction, both primary and secondary research, comes to a design brief or redoing the brief again, generating many concepts, alternate concepts. You make prototypes out of these concepts, you test and evaluate it. Based on that feedback, you finally come out with the final solution. So, agriculture in India, right? It's demographically the broadest economic sector in the country. So, according to the 2018 survey, it ranks second worldwide in farm outputs and ranks first in the world with highest crop area, followed by US and China. That means we have the largest area for agriculture in the world. If you look at it, about 329 million hectares, out of which 160 million hectares, almost 45% of the land is suitable for growing crops, and we have 100 million farmers with 160 million hectare land for agriculture. The student also looked at inputs from the secondary research and the statistics, and he realized that there are a lot of marginal farmers. They hold small pieces of land from 3 to 7 acres. Their income is not that much for them to afford, equipments which are high-end equipment for spraying. Okay. So, so that was one, finding he had. The small farmers with less land, okay, need something which is affordable for them. Okay. And that means that it gives an opportunity for designing a sprayer which is meant for small and semi-medium landholding farmers. Okay. So, once you kind of identified the segment that you want to build this to, looked at all the alternatives of spray machines which are available in the market, from the ones which you put on your back to one which you can carry with you, to motorized ones. So, there were several alternatives and also of varying price range. So, from his again secondary research, Most of the farmers use manual and battery or powered knapsack. So you can see that it's like a backpack which you put on your back, and you have to carry this heavy load to spray pesticides. Yeah, so they prefer this, okay, and it's difficult to use it for a long period of time because you're holding about 20 liters of liquid. It has problems in loading. There are vibrations, okay, yeah, and also the mechanism itself can be improved, and they're also exposed to all this, the pesticide spray itself, right? So these were some of the issues. Okay, so the student did primary research, that means going to the field. He did many visits like this. So he was in Bombay, so you can see that he's gone to Satara to understand how it is, the conditions of the farmer, and to collect first-hand information. Okay, and it's also experiential because when you go to the field, you interact with the farmer, see how he uses the equipment and discuss with them, and that's how you do your primary research, right? By conversing with them, taking down notes. So he had two parts to it. He had a questionnaire through which he got primary data, as well as he interacted with the farmers, asking them, talking to them, finding out, trying to assemble it. Yeah, so he had a lot of data which he collected out of it. Okay, he looked at the kind of crops they make and what is their annual income, the Kharif crops and the Rabi crops. Okay, he had also had a look at the components of the system, sub-components, what you can change, what you need, what are the maintenance issues with that. Then he also had the equipment demonstrated, first by the farmer, then he himself tried to use it, put it onto his back and go and spray. And he had a lot of issues. If the wind is against you, then you get it onto your face, coughing, sneezing, headache, skin issues. So there are some things, physical strength, for example, and so it means that you need to be an able person to do it. So, others cannot actually make use of it. Okay, so these were all his findings, and he also located where actually the pain points are. Okay, so there's pain both in the shoulders, back and arms. Okay, all ergonomic issues. Then he came out with a design brief, design a solar pesticide sprayer for agriculture use in India. Solar because it, it charges it, okay, and it has to be affordable to small and medium sized farmers, easy to take it in between the crops. It should be comfortable to use than the ones which are carried on your back. Solar powered because it can generate and operate a motor, so it reduces the human effort. And yeah, he looked at multifunctional and additional product value for farmers to increase the use of this device. And can it be manufactured and maintained and repaired at the local level? Very interesting question. He doesn't have to run to this next town to repair it, but can he actually maintain it? Okay, so these are all nice design briefs. So possible directions. Okay, one is that if he doesn't have to carry it, he can push it, he can pull it. Okay, or maybe there's a more effective way to carry something, right? So these are the options that you have. Then even in push types, there are many variations of it, right? So again, so these are all part of the ideations. Where do I put the center of gravity? How do I hold it? What is the dimensions of it? How do I put the solar panel next to it? So many options. So this is one of the options: adjustable height, adjustable nozzles, battery pump, that's the solar panel, and that's the modular tank, right? And then if it is a pull type, okay, so again you get many variations of it. Okay, pulling is much more easier than pushing. You can use your body weight to also pull it here. So that's an option. Okay, so here you can see it's tied onto his waist, and it's like a small cart which comes behind him, and he's spraying. His hands are free to spray. Yeah. and there can be many variations of it, whether you should rest it on your shoulders. Okay, so these are questions. Okay, so alternatives come in. Okay, then comes to making models out of it, right? Idea, for example, decided to use pipes to make the structure, put the tank in the middle, and then you have something which you can push and test it. So he's doing it. So this is the push one. Okay, he's got his friends to do it. He himself is doing it. Okay, he also looked at the size measurements of the human being, so you have to match it with that, right? So you can see that according to your anthropometric measurements, you take the one which is most comfortable for Indian human dimensions and map it onto it. Okay. So now you have another solution where you can actually pull it instead of pushing it, right? So this is his mock-up 2, used a scale to do it. Okay, so these were wireframe ones, just to test it out. Then he did the actual one. That's the development phase of it. He's got all the pipes here, assembled it. Now they are testing it actually. You see he's got his colleague, to come and help him, so he can test it out with both males and females. So that's something which you can do. And then he had many ideas. Okay, there are 4 ideas which were ranked according to different criteria and evaluated, and then he had some scores which were much better than the other. The pull type mock-up 3 and 4 scored much better than everything else. So maybe he decided this was the mock-up 3 and that was the mock-up 4. Mock-up 3, for example, you see that the wheel is behind and then the pesticide container is in between. In the next one, the wheel is ahead and the pesticide container is at the back. It kind of balances it out. So this was the revised model. Okay, so you had this with the container and the load is distributed around. Okay, and yeah, it's the portion to pull it is around your waist instead of your shoulders. So this is a little more detailed version of it. You can see that the hook joint for connecting it to your body, and that's the tank position. You can see where the solar panel is there, and he's used 2 wheels for stability. Another detail from that, the pipe management, so you can shift it a little bit here and there. Yeah, so it's kind of flexible, and so he did the cost estimation here. So everything works out to about 5,000 rupees, which for him was a very reasonable amount for something like this. And then he did an objective check. Okay, so it means it's affordable to majority of the small and semi-medium farmers. Easy to take it along the crop, between the crops. It's comparatively effortless and comfortable to use than the existing ones which you have to take it on your back. It's solar powered, so it's an automatic spray. It reduces human efforts. It's multifunctional with additional product value for farmers to increase the frequent use of the device, ability to manufacture, maintain and repair at the local level, because there's nothing big about it. It can be done in a small workshop. That's the final product, and it's put, all the components and the drawings are put almost like an open source, so that you can easily adopt and make this happen. So just to sum it up again, you'll see that the student has done both secondary research from existing data and surveys. He got the numbers and facts right. He went to primary research. He went to about 4 places, talking to the farmers, looking at the way they use the pesticide machine, trying it out himself, finding out all the issues and problems, redefined his problem. For example, he said that, can I make it at the local level? That was one of the inferences he got from looking at the market. Then he came here, did ideation, did 4 different variations of it, got feedback and combined some of them to make it much better, and finally did the mock-up, and the actual prototype used it, got the feedback, and he was convinced that that's the way to go about it. Did the costing part of it, which is not too much, and it fits in with the user segment he was trying to do here. So this is a simple product design project using the design thinking and innovation process, going through the different phases of it and coming out with a final solution. So thanks a lot for listening. So that is section C4, week 4. So let's summarize now. We looked at the secondary research, part 2 of it, further understanding the users. We used a very interesting mapping of the different participants, and then further research, and then we looked at the case study here, solar powered pesticide sprayer. Let's have a look at week 5, the coming week. We move on to primary research, how to do conversations with the users, how to administer questionnaires, how to get narratives out of users, ask them to tell stories. We also look at a very interesting tool, the contextual inquiry tool. Then we apply it in the project. We do both primary research as well as contextual inquiry, and then have a project which makes use of this. It's a smart control system for bedrooms.